Hi, this is Mr. Blystone, and we're starting with video 1 for Unit 1 in Algebra 1, and we're talking about variables in sentences. So you know, for the future videos, most of the Algebra 1 will start off with some type of example that kind of leads us off to see what topic we're talking about. So let's look at our motivating kind of idea. So there's an old rule of thumb for estimating your distance from a flash of lightning. You determine the number of seconds between the flash and the sound of thunder, and you divide the number by 5, and that's about how far you are in miles. So, if you count 10 seconds between the flash and the sound of thunder, you're about 10 over 5, 10 divided by 5, or 2 miles from the lightning. Not too bad. Pretty easy to do, and you can try this at home, and it's pretty accurate. It's approximate, but it's pretty good. So if they're right next to each other, you're pretty close. So let's see how we can talk about this. So in the language of algebra, we could say it like this. If S is the number of seconds, S for seconds, between the flash and the thunder, then S divided by 5, or we could also say S over 5, is your approximate distance in miles from the lightning. And the letter S is a variable. So a variable, what is a variable? A variable is a letter or other symbol that can be replaced by any number or other object from some set. The next video we'll be talking about sets, but basically we can replace it by any number from a set. We could use capital or lowercase letters. Now, a little thing on that. We want to be careful. There are certain ones we don't use, ever. We do not use E. We do not use I. We do not use O. Those 3 letters are not used. You'll learn more in later courses why E and I aren't used. O, because it looks too much like 0. Also, we are always careful with T's, or I try to write a T kind of like this, so that you can tell a T from a plus sign. Now, will it always happen in these videos? I'll probably make the mistake at some point, but I will try to erase it and be sure. So variables could be either capital or lowercase letters. We could also use a capital A, for example, or a capital C. Those are fine. But E, I, and O are generally things we don't use. Even capitals, we try to avoid them. So if M is your distance in miles from a flash of lightning, then we can say M equals S divided by 5. And we read that sentence, M equals S divided by 5, M is equal to S divided by 5. Some will also say S over 5. Both work. It means the same thing, over or divided by. All right, so let's talk about sentences now. We know what a sentence is in language. A sentence is basically a unit that has a subject and a verb. It tells what someone or something did. It gives an action or a state of being and a thing. In math, a sentence is a grammatically correct set of numbers, variables, or operations that contain a verb. Math has verbs, believe it or not. We're going to look at some of the main verbs in math. One such verb uses equation, makes an equation. A sentence using the verb equals is equal to. That's an equation. Things that are equal on both sides is an equation. We're going to see a lot of equations in algebra. That's a big part of algebra. So let's look at some of those other verbs. So here's a little chart of some other ones. You've probably seen these. If you haven't or you're not sure about them, you might want to pause the video and write them down. So we have the symbol is not equal to. We have less than or equal to, approximately equal to, greater than, and greater than or equal to. These top 2 are not used as much. They have some uses, but not too much. They don't tell us much. Something not equal to something else doesn't tell us much. In certain cases, there are times when we will see it, but not too often. And approximately equal to, that's usually used like very rarely. These 4, however, are used, and the equal are used a lot more. And so a sentence with one of these is called an inequality because it's saying it's not equal. So let's look at our first example. It says write an inequality that compares 1/3 and 3/8. Now, we're not going to use is not equal to because obviously they're not equal. We know that. We're pretty sure 1/3 and 3/8 aren't equal, so we're not even going to bother because that's one of those, like I said, that's a cop-out exam inequality. We're not going to do that. We need to figure out greater than or less than. So let's think. 1/3 and 3/8. Well, these two fractions have different denominators, 3 and 8. We can't really compare things with different denominators easily, especially when we have some that really aren't too, like 4 and 8's easier. 3 and 8 isn't. So we need to find a common denominator, something they have in common. So let's think. Well, if we go through the multiples of 3, we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I'm going to stop at 30. I think we don't need anything above 30. Let's go with 8. We have 8, 16, 24, 32. But wait, I'm already saying we're already above 30 there, so we don't need to go any farther with 8. And already I see a matching one, 24. So 24 is our key there. We can make these denominators 24. You should probably remember from school before this how to do that. So what changes the 3 to 24? 8. So we're going to multiply 1/3 times 8 over 8. And that's going to, 8 over 8 is a special 1. It's just 1, remember. But it's transforming it into 24ths, and that makes it 8 over 24. And we have 3/8. 8 times 3 is 24. So we multiply by 3 over 3. Again, a special 1. And that's equal to 9 over 24. Well, now we can compare. 8 over 24. Oops, not 87. Let me erase that. 8 over 24 is clearly less than 9 over 24 because 8 is less than 9. And 8 over 24 was 1/3, and 9 is 3/8. So we can say our final answer is 1/3 is less than 3/8. And we can box in our answer there. 1/3 is less than 3/8. That's the answer. Pretty simple. So let's look at a you try. Here's your you try. Write an equality that compares 6/11ths and 1/2. I will tell you pause the video and see if you can answer this question by yourself. I'll give you just a chance. Pause the video. So now I'm going to answer the question. 6/11ths and 1/2. Again, not easy to compare. So if we think about this, let's see here. 2. Well, let's do the same. Let's not count out the numbers this time. Let's go ahead and do what we did last time. Let's see if we can make them into something equal. Well, let's see here. What if we just go ahead and multiply 6/11 by 2? Well, 6 over 11 times 2 over 2, a special 1, is equal to 12 over 22. And if we do the opposite thing, 11 over 11, another special 1, we get 1/2 times 11 over 11 is equal to 11 over 22. And so we can see that 12 over 22 is greater than 11 over 22. Or, going back to the original, 6 over 11 is greater than 1/2. Now, I didn't tell you on the last one, we could write this a different way. We could flip it. We could say, let me box this. We could also say that 1/2 is less than 6 over 11. Both of these are correct. They both have the same meaning. 1/2 is less than 6 over 11. 6 over 11 is greater than 1/2. Either way, same thing, we're good. All right, so now let's talk about open sentences and a solution. An open sentence is just a sentence with a variable. It's called open because we can't determine until the variables are replaced by values. So until we put some type of value, we don't know what its value is. It's open. A solution makes it true, makes both sides of that sentence correct. If it's an equation, it makes them equal. If it's an inequality, it makes the inequality true. Okay, a next example. It says, which of the numbers, 7, 8, or 9, is a solution to the following open sentence? We have 3 times x plus 15 equals 4 times x plus 6. So basically what it's saying is we need to replace each of those for x and check and see if it's true or not. So let's try it. So let's just go one at a time. 3, remember the dot means multiply. Dot 7 plus 15 equals 4 times 7 plus 6. Now, we've got to remember our order of operations, which we'll look at on a following slide, but just remember, parentheses. You know what? I'm going to write this a little bit easier for us right now. Just so we can kind of, in parentheses, exponents, we'll call this exponents, then multiplication and division, and it's going this way, whatever we see first, and then addition and subtraction, whatever we see first. So on these two, on multiplication, division, and addition and subtraction, if division comes before multiplication, we do it first. If subtraction comes before addition, we do it first. It doesn't mean multiplication always has to be before division. It means in whatever order you find those two, you do the first one of those two you find first. So you do, if division's the first thing, after you cleared parentheses and exponents, if you see division and then there's a multiplication letter, you don't do the multiplication first, you do the division because it's first on the left. So, let's see here. Do we have parentheses? No. Do we have any exponents? No. Do we have multiplication or division? Yes, we have multiplication. Our multiplication is here and here. So we do those first. 3 times 7 is 21, so let's want 21 plus 15 equals 4 times 7 is 28 plus 6. 21 and 15 is 36. And 28 and 6 is 34. Does 36 equal 34? No. So 7 is not our answer. I make sound effects. All right, so let's see if we can find out another answer. I'm not going to erase, I'm just going to move down here. All right, so now let's try for 8. 3 times 8 plus 15 equals 4 times 8 plus 6. All right, so 3 times 8, 24, plus 15 is equal to 4 times 8, 32, plus 6. 24 and 15 is 39. 32 and 6 is 38. Not equal. All right, let's do one more. Let's do 9. So, according to that, so it's not 7, it's not 8. Let's try 9. So we know it's 3 times 9 plus 15 is equal to 4 times 9 plus 6. 3 times 9 is 27 plus 15 equals 4 times 9 is 36 plus 6. 27 and 15 is 42. And 36 and 6 is 42. 42 is equal to 42. They check out. And life, the universe, and everything has meanings. So the answer to our problem, because we wanted to know, is it 7, 8, or 9? The answer is 9. 9 is the solution. It's the following open sentence. All right. So now you can try. Which of the numbers 4, 5, or 6 is a solution to the following open sentence? We have 9 minus b equals 4 times b minus 11. Remember the order of operations I told you before. I'm going to remind you. Parentheses, exponents, and we have multiplication, division, in order from left to right, and then addition, subtraction, in order from left to right. So pause the video, try this one, see if you get it right. All right, if you're back, let's see if you got this right. 4, 5, or 6, we need to check. So our first one, 9 minus 4 equals 4 times 4 minus 11. All right, we start off with multiplication. 4 times 4, 16. And we got some subtraction here. 9 minus 4 is 5 equals 16 minus 11 equals 5. 5 is 5. We're good. Now, let's make sure that none of the other answers are right, because 4 is okay so far. But let's just make sure, because it could be it's true for other numbers, not just 4. Sometimes sentences have more than one possible answer. So let's see. 5. So 9 minus 5 equals 4 times 5 minus 11. 4 times 5 is 20. 9 minus 5 is 4 equals 20 minus 11. 20 minus 11 is 9. We have 4 equals 9. No, not true. 4 is not equal to 9. All right, so let's try our last case, which is 6. We have 9 minus 6 equals 4 times 6 minus 11. All right, 4 times 6 is 24. 9 minus 6 is 3 equals 24 minus 11 is 13. 3 is not equal to 13, so that's not the answer. So our answer, without a doubt, is 4. 4 makes that open sentence true. Pretty easy. All right. Next question. Find all solutions to p squared equals 36. So hopefully you remember about numbers that are squared. Remember, p squared means p times p. So p times p equals 36. So something times itself is equal to 36. So if you didn't know, if you only knew that much, we could try and see if we could do what we call brute force. Brute force is where we just go and try and find it, going step by step. Okay. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Let me rewrite that 5 there so it doesn't look like a 0, so you can make sure you know it. 6 times 6 is equal to 36. And stop. That's the answer we want, 36. So 6 times 6, so P is equal to 6. And that's our answer. Is it? Find all solutions. 6 times 6 is 36. And clearly, as our number double, it's the only one we think about. But there's something we've missed here. We have forgotten about negative numbers. Negative numbers, remember, a negative times a negative is a positive. So because of that, we have to think of negative numbers. Well, since a negative times a negative is a positive, we know 6 times 6 is 36. So we can also say that negative 6 times negative 6, negative times negative is a positive, is 36. So we have two answers. P is 6 and P is negative 6. For all questions that are something squared equals something, we can have two answers, a positive and a negative answer. Remember that. That's important. Now, there was another way to do this if you remembered from other classes in the past. It's called the square root. And if you know your square roots, this is what you do. We say P squared is equal to 36. So now we're going to learn the first commandment of algebra. The first commandment of algebra says what you do to one side of an equation, you have to do the exact same thing to the other side. We saw that with the fractions when we were multiplying by a special 1. Multiplying by 1 is the only exception, because multiplying by 1 doesn't change anything. But we have to do the exact same thing to both sides to keep it true. So we're going to take the square root. We take the square root of a number. Now, the rule says the square root of something squared is something you may remember called the absolute value of a number. Square root of 36 is 6. But the absolute value, remember, turns anything in that it takes away the sign. It basically says whatever it is, 6. Well, what things could be 6? Well, 6 and negative 6, just like we had earlier. Those will both, the absolute value of 6 is 6. The absolute value of negative 6 is also 6. So that's our answer. A little bit tricky, a little bit hard, kind of having to remember some pre-algebra there, but just to get you warmed up. So here is a you try problem. Find all solutions to a squared is equal to 64. Go ahead, pause the video, see if you can do this one. Again, a calculator may be helpful, but these are ones you should be memorizing in putting in your mind. All right. So remember that a squared equals 64. A times a is equal to 64. Now, we could just, I tell you what, let's go on from our example. Let's do it the brute force way real quick. We know that 6 times 6 is 36. So we know it's not less than 6. We know 7 times 7 is 49. We know 8 times 8 is 64, and that's what we want. So we know that A equals 8. Remember what we said? That squares have two possible answers, a positive and a negative, and A is equal to -8. Remember, we could do it the other way. Square root. Well, let's write it out before we put the square root. To be fair, let's do this the right way. Let's not take shortcuts. A squared is equal to 64. We take the square root of both sides. Absolute value of A is equal to 8. That means A is 8 or A is -8. Again, easy peasy. Let's go into another example. Water will remain ice for all temperatures less than 0 degrees Celsius. We need to write an open sentence describing this situation. Okay. Well, we're not worried about water will remain ice. That part we're not worried about. That part is just kind of extra nice to know information. So let's just mark that out. We have temperatures less than 0 degrees Celsius, less than, and temperatures and 0 degrees Celsius. So, open sentence. When it's ice, our temperature, T, and we'll call this part A, T, temperature, is less than 0. T is less than 0. Do we need anything more? No. T is less than 0. Okay. B, give 3 numbers that make the sentence true. Well, we can use any 3 numbers. We could say one number we know is -1. That makes the sentence true. We can prove it. -1 is less than 0. We could say -5. -5. We rewrite that. Is less than 0. We could say -999. Not that it would ever get that cold, but -999 is also less than 0. Those are 3 numbers that make it true. Again, not too bad. All right, now I'm going to give one to you to try. It says the population of the United States is greater than 250 million people. Write an open sentence describing the situation. Give a number that makes this sentence true. Pause the video, see if you can do it, and come on back. And I'll give you the answer. All right, so population. Well, I like T for population. We have greater than 250 million. Now, in this case, I don't mind doing something. I'm going to show you 2 ways to do this. Both I have no problem. So, population, let's call this part A, T, greater than 250 million. Now, if you wanted to be really mathematical about it, you could also, and probably should, write T is greater than 250 million. If it's me, I'd accept A. The first one is fine. Some people, they want you to write out the number. Show that you know how to write out a number. That's fine. Both work. All right, give a number that makes the sentence true. You could have said 300 million. You could have said anything bigger. I would say, let's have a little fun. 250 million and 1. That makes the sentence true. That's greater than 250 million. There you go. Just to kind of preview something. An answer you could give, but that really wouldn't make sense. It's partially true. We could say 250 million 0.5. But we can't have a half a person. So in this case, it wouldn't exactly make sense. So in this case, it would not be a good answer. It is true mathematically, yes, but for our problem, it's not a good answer. So be careful. Think about what makes reasonable sense. All right, if you're following along and you are doing this as a homeschool or some type of study course, I would suggest you try problems 1 through 23 in section 1.1 of the algebra book. If you have any problems, questions, leave it in the comments. I'll try to get back and answer them as I can. Have a wonderful day and keep on learning.